Hello dear students, welcome back again to Chinmoyee's biology channel. So this is for my 8th CBSE students. So let us get started with a new lesson, that is your 4th lesson, combustion and flame. What we are going to learn today? We are going to learn today about what is combustion, what is ignition temperature, what are inflammatory substances, and we will learn in brief about the history of a matchstick and this how to control a fire, or what is a fire extinguisher, that we are going to learn in the next lesson or in the next class, because today it will be very big lesson if we are continuing with this one also. So this we will continue in the next lesson. Today we will be going to cover the first 4 topics. So for that, for the upcoming videos, you need to stay tuned with all my videos. You need to subscribe to my channel and please do share it with your friends as much as you can. So without wasting time, let's get started with today's episode of combustion and flame. Temperature. So the first lesson today we are going to start is combustion and flame. We generally use many substances in our home which are used for burning, and in automobiles as well as in industry also we are using certain substances for burning, or they are different kinds of fuel also. Okay, so first we will name some fuels which are used in trade and industry as well as in home. So what are those? Cow dung, wood, charcoal, coal, petroleum, diesel, compressed natural gas, that is CNG. We can also say LPG, that is liquid petroleum gas. These all are used as fuel. So we can handle certain types of burning at home. We know that burning of a candle is also burning, whereas burning of a gas or a LPG, liquid petroleum gas, is also burning. Burning of a charcoal is also burning. So what is the difference between the burning of a candle and the burning of a coal? Okay, so we can say that candle burns with a flame, whereas coal doesn't burn with a flame. So that is the simple difference between a candle and a coal, burning of a candle and a coal. So similarly, we can find out many other materials which are burning without a flame. So let us now study the chemical process of burning and the different types of flame produced in the process. So what we are going to discuss today, we will discuss about the different types of flame also. We will discuss about the process of burning also. So what is combustion? First we should know that. So we should know, or define rather, what is combustion. So once you start recalling what you have studied in the previous class, you will remember that you have burnt the magnesium ribbon in class 7th. So there was an activity that when magnesium ribbon is burnt, it forms magnesium oxide and produces heat and light. So there was an activity you did with the presence of your teacher in class. So magnesium ribbon was burnt, and which was giving magnesium oxide, which produces heat and light. So we can perform similar kind of experiment with charcoal. We can hold the charcoal with a pair of tongs and we can bring it near the flame of a candle or a Bunsen burner. So what do you observe? We find that charcoal also burns in air. And this charcoal, it is producing carbon dioxide, heat and light. Is it clear? So they are both burning. One is burning with a flame, another is burning without a flame, but both are giving carbon dioxide. In charcoal, if it is burnt, it is giving carbon dioxide, heat and light. Now, what is the definition of combustion? So, what is combustion? A chemical process in which a substance reacts with oxygen to give off heat is called combustion. So, this is very important. This is the definition of combustion, right? So, when a substance is reacting with oxygen to give off heat is called combustion. Now, the substance that undergoes combustion is called a combustible substance. So, if the substance is not undergoing combustion, it is called non-combustible substance. If it is undergoing combustion, it is called combustible substance. If it is not undergoing combustion, it is called non-combustible substance. And it is also called fuel. So what is fuel? Anything which burns is fuel. Fuel may be solid, fuel may be liquid or a gas. And sometimes light is also given off during combustion, either as a flame or as a glow. So this is very important. Now we have discussed about the reactions with magnesium, charcoal and other combustible substances. So we every time your mother keeps on telling that you should eat well because food is the fuel of our body. So if food is the fuel of our body, what is happening inside our body? So is some process like combustion happening inside our body? Yes, it's true. Something like combustion is only happening inside our body, but in our body, the food is broken down with the reaction of oxygen, and heat and energy are produced. So that process is not called combustion. In factories, in automobiles, in industries, it is called combustion. But in our body, the process is called respiration. Okay, so in our body, it is called respiration, where we are taking in oxygen and in different types of, in different cells, it's being burned, it's being breaking down the glucose to liberate energy and heat. Okay, heat and energy are liberated. Now here two activities are given which we can do with caution and in presence of our teacher in school or at home. If you are doing, you should do these in presence of your parents or guardian. Okay, so we will do these activities in the next slide. Activity 4.1. What is there in this activity 4.1? We are collecting some materials like straw, matchsticks, kerosene oil, paper, iron nails, stone pieces, glass, etc. So, under the supervision of your teacher, try to burn these materials one by one. If combustion takes place, these materials are marked as combustible. If not, they are called non-combustible. Okay. So, now this is the column. Here, if it is combustible, you will write it, put it under combustible. If not, you will put it under non-combustible. It is very easy. Just take these substances, you try to burn it, or you try to light it like charcoal, straw, whatever is burning, it will be combustible. Which one is not burning, it will not be a combustible substance. It's a non-combustible substance. So can you name some more substances which are combustible? You add those. If you can think of many more substances, you can add to this chart also. So let us investigate conditions under which the combustion takes place. So what we are going to investigate now? Conditions under which the combustion is taking place. Now here also they have given you an experiment. Fix a lighted candle on a table. You are fixing the lighted candle on a table. Put a glass chimney over the candle and rest it on a few wooden blocks in such a way that air can enter the chimney. You can see here it's resting on two wooden blocks. It's resting on two wooden blocks which are showing that we can say that air is passing through it, right? So it is resting on two wooden blocks which showing that air is passing into it. Okay, observe what happens to the flame. Now you are removing those two blocks in this B. Okay, no blocks are there and they are resting on the table. Again observe the flame. We are again observing the flame. Finally we are putting a glass plate over the chimney and watch the flame again. So here also we are putting a glass plate over the chimney and we are watching what is happening. Does the flame flicker and move off? Does it flicker and give smoke? Does it burn unaffected? And can you infer anything all about the roll plate by the air or oxygen in the process of burning? Okay, so many questions they have asked you. First of all, does the flame flicker off? That is, after flickering off, it is putting off the flame, or it is burning with a smoke, or it doesn't flicker, only give you a smoke. So many questions arise in our mind. So how we can answer this? Just let us find that what is happening. So we find that for combustion, air is necessary. So the candle burns freely in case of A. So just look at the A1. We have put two blocks so that the air can pass or move in freely. So when the air moves in freely, what is happening? The flame is burning. Candle is burning freely and where air can enter the chimney from below. In B, what is happening when the air does not enter the chimney from below? The smoke flickers and produces smoke. So the flame is flickering and it is producing smoke. And in case of C, the flame finally goes off because air is not at all available, because we have covered the top also and the base also doesn't have any entry of air. So the flame is putting off. So here, as some oxygen was there inside, it was flickering and then it is producing smoke. So in the case of C, the air is not available and the flame goes off. Right, so these are the conclusions from these two experiments. Now let us move on to what is ignition temperature. Now, what is ignition temperature? Okay, you can see here ignition temperature, that the lowest temperature at which a substance catches fire, it's called as ignition temperature. So this is very important. This you should know as a definition. So what is ignition temperature? The substance is catching fire at a certain temperature. So the lowest temperature at which it catches fire is called ignition temperature. So let us see some examples or experiences where we can tell that different substances catch fire at different temperatures. Now you see here, place a piece of burning wood or charcoal on an iron plate or a tawa, cover it with a glass jar or a tumbler or a transparent plastic jar. Observe what happens. Does charcoal stop burning after some time? Can you just think the reason why it stops burning? You might have heard when the clothes of a person catch fire, the person now you can now recalls we can say that is covered with a blanket to extinguish the fire, and can you guess why? So here the person caught fire and we are just covering him with a blanket so that fire is put off. Now, does a matchstick burn by self? How does it burn? So there are several questions in our mind. You must have had an experience of burning a piece of paper. Does it burn when a piece of matchstick is brought near it? So how does it burn? Can you burn a piece of wood by bringing a lighting matchstick near it? What do you have to use? Or kerosene oil to start fire in wood or coal? Have you heard of forest fires? Okay, so all of a sudden if you hold the paper in front of a candle, it may catch fire. But if you are holding a piece of big wood in front of candle, it will not catch fire. It needs to be damped or made wet with kerosene oil to start the fire in wood or coal. Okay, so without that it will not be inflammable, it will not burn properly. Have you heard of forest fires? Yes, during this summer month when it is too hot, we at some places dry grass catches fire, and from the grass it spreads to trees, and very soon the whole forest is on fire, and it is very difficult to control such fires, right? So from that only we can conclude that the lowest temperature at which a substance catches fire is called ignition temperature. Now, can you tell me why a matchstick does not catch fire on its own at room temperature, and why does the matchstick start burning when you are rubbing the matchstick with a matchbox? Yes, we do know when we are rubbing the matchstick on the side of a matchbox. So there is a bit history. So we are going to learn that history now. So here we are back with the history of matchstick. So the history of matchstick is very old, more than 5,000 years ago. Small pieces of pine wood dipped in sulfur were used as matches in ancient Egypt. So Egyptians used to dip small pieces of pine wood in sulfur, and the modern safety match was developed only about 200 years ago. So what is happening here? What is the chemistry behind a matchstick? A mixture of antimony trisulfide, potassium chloride and white phosphorus with some glue and starch was applied on the head of a match made of suitable wood. When struck against a rough surface, white phosphorus got ignited due to the heat of a friction. Okay, so this started the combustion on the matchstick. However, white phosphorus proved to be very dangerous both for workers involved in the manufacturing factories and for the users. So they used to use white phosphorus which got ignited due to the heat of friction. So when we are rubbing the matchstick. So now for that, what we have used now these days, the head of the safety match contains only antimony trisulfide and potassium chloride. Okay, so rubbing the surface has powered the glass and the little red phosphorus, which is much less dangerous than that white phosphorus. So red phosphorus is being used, which is less dangerous than white phosphorus, which was used earlier. So when the match is struck against the rubbing surface, some red phosphorus gets converted into white phosphorus. This immediately reacts with the potassium chloride, and the matchstick head it produces, ignites the matchstick head, and we can light something from the matchstick, and it heats to ignite the antimony trisulfide and start the combustion. Okay, so immediately after rubbing, what is happening when the matchstick is struck against the rubbing surface? Some red phosphorus is converted to white phosphorus, and it immediately reacts with potassium chloride and the head of the matchstick head to produce the ignite the antimony trisulfide and start combustion. Is it clear? So this is the history. Just go through it, just read it. Now if we cannot find a combustible substance, like just a combustible substance that can catch fire or burn as long as the temperature is lower than the ignition temperature. So it can only catch fire when it has reached the ignition temperature. However, you have seen that cooking oil catching fire while frying pan is kept for. Have you ever seen a cooking oil catching fire if it is kept for on the pan also for a long time? Kerosene oil, wood do not catch fire on their own at room temperature, but if kerosene oil is heated a little, it will catch fire. But if wood is heated a little, it would still not catch fire. Does it mean that the ignition temperature of kerosene is lower than that of wood? Does it mean that we need to take special care for storing kerosene oil? The following activity shows that it is essential for a certain substance to reach the ignition temperature to burn. So if you are keeping kerosene oil at home, yeah, obviously it should be kept with great care so that it should not reach that heating point or that ignition temperature also where it gets inflammable, where it starts burning. So whenever you are preserving or storing this kerosene oil or petroleum at home, you should preserve in that spot which is cool, which does not reach the ignition temperature, right? So let us move on to this activity. So we are starting with this activity 4.4 here. So caution should be taken while handling this burning candle. So what we are doing here, we are making 2 paper cups here. We are taking 50 ml of water in one of the cups, and we are continuing to heat both the papers. In one paper no water is there, whereas in another one there is only 50 ml of water. Okay, one no water is there and another 50 ml of water is there. So what is happening after it is heated for some time? So what happens to the empty cup? What happens to the paper cup filled with water? And does the water in the cup become hot? So what are the things which are happening? So if we continue heating the cup, we can even boil water in a paper cup. So can you think of an explanation for this phenomena? Yes, we can think. Obviously, the heat supplied to the paper cup is transferred to water by conduction. So heat from the paper is transferred to water by conduction, and so in the presence of water, the ignition temperature of the paper is not reached and hence it does not burn. Okay, so the substances which have very low ignition temperature and can easily catch fire with a flame are called inflammable substances. So what are inflammable substances? They are LPG, alcohol, petrol, etc. So they are having very, very low ignition temperature. So at a very low temperature only they can catch fire simply, and they can with flame also. So the homework is that you should make a list of substances which are inflammable, which are producing flame, or which are catching fire at a very low temperature. So this is all for today's episode, and I am giving you a homework that you can list. You should list a few inflammable substances. So this is your homework. So in the next class we will come back. I'll ask you that what are the list of inflammable substances. Please do write in my comment box. And in the next class we will start with how do we control fire. That is, we will learn about the process of a fire extinguisher and all. So till then, subscribe to my channel, stay tuned, stay updated with all my episodes, and please do share it with your friends so that all can learn the lessons in a simple and easy way. Thank you.